Hello, everyone. I think we're live for Beyond Machines' first webinar dedicated to data engineering. I'm here with
Hi, I'm
our
Vladislav.
trainer,
Nice to see
Vladislav.
you.
And for all of you that do not know yet Beyond Machines, so we're a community in Berlin, and we take care of connecting our community to the best minds in Europe and worldwide that are working and studying in the fields of machine learning, data engineering, blockchains, and deep tech. So today we're doing our first webinar that we're giving for free to our community for a topic that is actually, to us, very important because it's very often overlooked by the people and the company we talk to, which is data engineering, processing of data, the elaboration of data, and giving this data to then the people and the libraries that they will apply them for data science or machine learning techniques. These compose 90% of the problems in the whole field of data science, and it's taken care of by only 10% of the people. So I think that Vladislav today will enlighten you on what is it about and what is the best way to approach it. Just a few words on Beyond Machine for us that don't know us, but also for our friends in our community. So we are.
That's the wrong one.
That's the wrong one. Sorry, guys. No, that's the correct one.
Oh,
yeah. So we are, as I said, a community. We're based in Berlin, and we help the people at our events. We help our network to get in touch with trainers, experts, and people in the field of data science, machine learning, blockchain. So what we do, we organize workshops and boot camps. These are 1 to 2 days events, deeply hands-on on these topics, taken by 20 to 30 people max. So it's a short group, very intensive, where people enjoy learning about these topics or deepening their topics if we're actually talking about advanced trainings. At the same time, of course, we do recruiting events, enterprise training for our corporate partners, and we do data science courses. So we will offer them this end of this year. These are longer programs, 6 to 8 weeks, with a degree at the very end. We cover all the languages and topics in data science, and from this year, we also giving workshop and boot camps on blockchains, which all of you actually require. Their events are usually visited by a mix between data scientists and data engineers, with some business intelligence people in the mix. And of course, since we're taking more software engineering topics, we will have more and more software engineers that are not pure data scientists in the mix. We partner with the best and worldwide known companies in the field of data science that are providing data science library, that are providing the cloud architecture for these techniques. So Google, IBM, Amazon, NVIDIA, they've all been at our previous events, and they all give us sponsorships and materials for our courses. So this is just a brief overview of one of our last events. As you can see, the classes are very tight. The courses are hands-on. It's a sort of like a community environment where everybody can stand, sit, lay on the couch, whatever they want. They just get hands-on experience on a specific data science topic. So our next event will be 19th to 20th of April. Will be a machine learning bootcamp on PyTorch and reinforcement learning. Then we will have end of April our first blockchain bootcamp, introduction to blockchain techniques and ICOs. And mid to end of May, we will have another machine learning bootcamp on advanced machine learning techniques. So Beyond Machine is made by me and Irene. These are our emails if you want to contact us. Lele@beyond-machine.com, Irene@beyondmachine.com, and we're open for any questions. And this is our website. Please go on our website and sign up for our newsletter to get to know about our next events. And now I will give back the room to Vladislav. Thank you, so guys.
Wow, thanks, Jelle. It's very nice to be here. I've been looking forward to give this webinar. for a few months now. So first of all, I would like to apologize for the delays. The reason is I got very unlucky with being sick. And I'm very happy to see a few of you here. So let's jump right into it. The topic of today's talk is, there it is, an intro to data engineering and the MVP data pipeline approach. As you heard, I'm Vladislav. And before we jump into this topic, here's a bit about myself. So my original background is in computer science. I was very fascinated by machine learning, computer vision, and data mining, data handling in general. And through coincidence, I would say, I got into the field of DevOps. I got a fascination for really huge infrastructure setups, for doing it efficiently and reliably, for all the stuff which is around it, like monitoring, automation, and the processes which I needed to run huge systems. And I worked in the field for a bit, but afterwards I decided to combine the two fields. So data on one side and automation and ops on the other side. And whoosh, then I've been doing data engineering consulting and building data pipelines for a living. And I've been focusing mostly on small data and growing companies. Afterwards, I've been co-founding a startup recently. And what we've been building a fascinating machine learning, deep learning application. We were applying artificial intelligence to social media marketing. So basically, we wanted to understand what kind of visual content performs well and be able to predict for companies what images they should post to reach their brand, their audience, I'm sorry. But when this was over, by now I went back to the ops field, and right now I'm doing a lot of stuff with Kubernetes. But I would like to tell you a bit about this data engineering part, which I think is very fascinating and very, very, very worthwhile. So when I've been consulting for companies, it's a while ago now, like, gosh, more than 2 years. My best clients, the ones which were most successful and which were the most fun to work with, most gratifying, they didn't have huge data. So think of a company which is helping app developers to promote their application on various web stores. You've got all these data in different stores, you've got all these tools, and you know that if you could get access to it, if you just could get it all somehow under control and extract it and evaluate it, you could be so much faster with serving your clients, and you could get a lot of value out of being in control of this data. And what I've seen with these clients is when we started talking, usually they were in a state where they already had a prototype. They had built something to make it a bit easier to work with data, but it wasn't quite there yet. So they've seen the value. They've seen, like, this happens if we have those automated scripts. This happens when we finally evaluate the numbers across different stores. But it's just not right. It's quite tedious to work with these prototype tools. And you can basically feel how time and money is being wasted. So when they got there, they were in a stage that they were using data, but it was very painful. And the questions usually were, how can we do better? We build these prototypes. Where do we go from here? This is the part where some companies go, we should hire a data scientist. And it's not quite wrong, but I think it's the wrong place to start, and many people would agree. Imagine you manage to hire somebody who qualifies for the term data scientist. First of all, this is not quite the position you're looking for to begin crunching your data. But anyway, imagine a data person is joining the team, and they are geared towards doing really smart stuff with the data, like doing fancy analysis work, building predictive models, all of this stuff. Here's what will happen. So first of all, the data is all over the place. Probably you've got some Excel files flying around, you've got several data sources, and you've got these, in the best case, you've got prototype ways of getting the data to work with. But then you get it and the data is really tedious. It's not cleaned up. There are lots of edge cases. Maybe when you're working with different teams, both have a different view of the same data, which is, maybe different Excel sheets, which are not quite right. And it's just no fun. So when you try to approach this problem as this new data person, you think about, oh gosh, what tools do I even use? What are the best practices? Like, I know how to build awesome models. I know how to create a dashboard, but I don't quite know how to create it out of 5 different Excel sheets. Do I really need to sit there all day copying data? And it's frustrating. It's a high effort work, and it's not sustainable. So sometimes people say, we need to use this new fancy tool, which certainly will help us get a hold of this data. And usually that's just not the case. So getting an overview of this field is quite hard. And into this could happen that they just intuitively go out and say, I think I got an idea how to solve all of this. I'll talk to you in 3 months. So they go off, they build something, and afterwards it's probably not the perfect solution the person has envisioned, because in the meanwhile the business has moved on, and they will not get 3 months to build the thing because people will be disappointed and will ask for results. So when a company goes, we need to hire a data scientist, I think this is not quite the right approach, and it's not the right issue to solve, because the problem with data scientists is they are pretty expensive. They get pretty good salaries. They're hard to hire because they're so popular. Many people want to have the best people, and they're easy to lose because when you're working at a company which is not quite the right place for you, what do? You get a new job, and it's not a nice thing for a person who wants to work with data and build awesome stuff, and it's not good for a company. So what should a company focus on before hiring a data scientist? And well, what do you need to do so this person can do their best work? Basically, you need to answer the questions: how can we work with our small data? How can we make it not as messy as it is right now, and maybe not as tedious, so the person who we're paying to do very interesting analytical work and maybe work with stakeholders to tell stories, to draw conclusions, so they don't have to work with 5 different Excel sheets. And here is where, in the best case, you would like to have a data team, because not everybody working with data is in the same place. There's the data scientist, and depending on the company and the people you talk to, all of those roles have slightly different meaning. But in general, you can say that the archetype of the data scientist is more of the let's apply code to build something which does fancy stuff. In some companies, it's building dashboards, and you're also working as an analyst. But for me, data scientist is something in the realm of really R&D and really let's apply fancy methods, which took a while and probably a degree to understand. Data analysts are the people who are working in SQL. They are helping management position people to get answers. They are doing the number crunching and maybe maintaining the dashboards. And data engineering is this kind of supportive role, which makes both of these tasks possible, or at least way easier. When you have a data engineer in your team, your data scientists can hopefully get clean data to work with. Once they build something, this is the person who helps them to get their predictive models into production. And when you got a data analyst, the data engineer people are those which help to build data warehouses, to get the data in one place and to make these analytical queries faster and simpler. So yeah, once again, data engineering. Basically, what this role is about preparing data for analytical and operational use. When you get data in many different places, you want to merge it. This is usually done by putting it all into a data warehouse. And there's lots of nuance to this. You've got operational databases, which you don't want to query directly when you've got a big live running system. You want to do it in a way which doesn't disturb operations, and then you want to put it somewhere where it's really efficient, something like AWS RDS. And the nitty-gritty part of working with data is you want to build reliable processes. So you're not the person who is doing the copy pasting from the Excel sheet every single day. You're building something which automatically and reliably does this kind of work for you, and maybe even tells you when something goes wrong. So very important things which one should know when thinking about data engineering is like, how do I build a data warehouse? How is it different? What are the right tools for particular jobs, and what can I reuse? How do I handle automation? How do I keep a system running? Like, what's monitoring? How do I handle logs? How do I scale a system if I need to? Probably you don't need to, but it's good to know. And how can I build a system which does not wake me up in the night? How can I build something which will not be broken for days and slow everybody else down? It's also a lot about saying, no, we should not do this. For example, you don't need to build a live data processing platform for most use cases. And even though some people might want it, you can say, we can get the same results by doing it technically easier. Anyway, data engineering, the goal is you want to have less manual work. You want to build something which is maintainable. You want to build something which is known to be easy to work with. And if possible, you have got enough knowledge to not reinvent the wheel, to make it easier for everybody. Okay, so now I've told you, companies, they want to hire data scientists. They should hire a data engineer first, because otherwise the data scientists will get grumpy and probably look for jobs all day. This might be a leading question, but no, I don't think you should jump into data engineering either. This is where I want to focus at what really matters when you work with data. And in my opinion, which might be biased because I've been doing this consulting thing, in my opinion, you should start with understanding the business. Because, building all of this data stuff, be it fancy analysis patterns or be it really, really nice ways to handle data, it's not as important as building the right thing. So some people might say, you need those dashboards, you need those tools, you need jada. I hope you were not expecting too many of those. There will be some content about this, but only in the net. In the end, in my opinion, all of this is more on the tactics side, and you will get way better results, before thinking about data engineering, before thinking about data science, if you think about the business. And this is what I've seen in companies I've worked with. It's a common pattern. When you start a project, when you start working with data, you get a lot of more support from people and a lot of more backing from the management part when you focus on getting results, when you get something out of your work in the beginning, which creates value for the business. And the best part, it's visible and measurable and has an impact on the company. So not just pretty dashboards, but maybe pretty dashboards which helped to acquire 5% more of something good, be it users, be it something tangible which relates to the business, some kind of ROI. And I can't say it enough, business first and then tech follows. Especially if you've got limited resources and especially if you are a young company. Mostly, in my experience, technical decisions are made easier when you know about the business. And data handling by itself is a small part of working with data, which I hope some of you will agree with. So it's not about building these fancy data systems. It's not about building these dashboards. It's also about working with people, about getting them to actually use the stuff you find out, to help people use the stuff you made as well. And when you start approaching this from the business part of the mindset is really, really, really important. You shouldn't consider any of those parts in isolation. And you might say, this is the third slide where I go into, business. Don't do tech, don't do data. Do business stuff first. Get it out of the way. Is it too obvious? And I don't think it is. I don't think it can be overstated. Let me take a brief detour. So I hope this is not too cheesy, but the detail I'm taking is sword fighting. Namely, in ancient Japan, there was this guy, which is depicted on the right side, Miyamoto Musashi. He was a very accomplished person, so martial artist, tactician, strategist, writer, philosopher, and also a sculptor. He lived quite a while ago, and there is a book which is in particular quite, well, not dear to me, but I like this. It's one of those books where you read a bit and then you put it down and you come back the next day because you probably did not get the meaning of those 3 lines. This is from the book. Allow me to read it to you. So he was writing about sword fighting. He was writing about advice for people who are learning the martial art, for his students in particular, what to keep in mind to be successful. So it goes, the primary thing when you take a sword in your hands is your intention to cut the enemy, whatever that means. Whenever you parry, hit, spring, strike, or touch the enemy's cutting sword, you must cut the enemy in the same movement. It is essential to attain this. If you think only of hitting, springing, striking, or touching the enemy, you will not be able to actually cut him. More than anything, you must be thinking of carrying your movement through to cutting him. You must thoroughly research this. So this is even more emphasis than I've been trying to put on this thing. And isn't this very obvious? Like when your goal is to fight somebody with a sword, you want to cut them. Why is this person from a few centuries ago going on about, how important it is to actually do the thing which you're obviously there to do? Why all this effort? And my interpretation is it's not as obvious when you are actually doing the thing. So even if you're a student of his, you don't actually think about why you're there, and your results suffer. This person would not go on and on and on about cutting the people if he wasn't really convinced that it would help his students. So in my interpretation, what I take from this is when you master something and when you want to get the correct execution, the mindset is really, really important. The core advice for me is that you have to have a goal-oriented mindset, and you have to have it at every step you take towards the goal. So that was it. Back to world of data handling businesses. So when you work with data, like when you think of hiring data scientists, when you think about working with your data, when you think about creating business value by doing data analysis or by building something which makes it easier, you should be thinking about the business value. Before starting it, while doing it, you have to be certain that what you're actually in there for is not to build the next fancy data system, but to do something good for the company and the people. And for this, you need to understand the business. You need to understand what it's about, how it works, and you need to be ready to learn and revise what you planned. So this really was a big part of my process when I was working with clients. When I finally knew about what I was doing, the first steps were always about the company and the client, about the people who work in them. I talked a lot. I tried to find out as much as I could, and I put it down in writing, because only when you let it, seep through onto the page, you really get the connections. You really understand what it's about, and you really can put the finger on what's actually important for the company in the moment. And usually the nice thing about this, usually the technology follows. If you've got a team of Python developers, then you know what technology you want to use to make it easier for them to handle their data. Depending on the tech stack, depending on the application, depending on the goals, you can say that some parts of the data are more important, some applications are more promising, and some ways to handle them will be better perceived by people. So how do you learn about what the company is actually about? You may be working at a company right now or be working at the company soon, but still I think it's very important to have this outsider's perspective. Ask yourself, what are the people actually working on? What's important in their day-to-day life? What will be used to measure their performance, not only the employees, but also the CEOs? What makes the business successful? What needs to happen more often? and what will it be worth to the business? And in general, to find this out, there's not only one person, but there's a whole, well, it's actually 4 people. It's on the one side, the people who are working with the application, if it happens to be a technology startup. And there's the person who is right now responsible for the data. This might be you. And there's also the business owner, the C-level people who maybe are looking towards the next founding round. And you want to get as broad an image as possible of the company to be able to decide on the technology, to be able to decide on what data needs to be handled what way, and to facilitate the work with data. So in summary, I went on and on about the business thing. Here's what I would have told myself when starting out consulting companies on data. I knew how to build data pipelines. I knew how to handle this whole automation stuff. But the focus on the company is really, really important to do a good job in data engineering, I think. You need to understand the business, and you need to keep the goal in mind of helping people. You need to keep the goal in mind, which you make possible by crunching the data. And also, it's really good to have a process. Anyway, on to the MVP data pipeline approach. So with all this in mind, like having the goal of helping the business, making it easier to work with data, and in the end, working with data, what can we do to be more successful? What can we do to make the work of data scientists and data analysts easier? And here's my approach. It's really, really simple. You want to start small and lean. You want to build the smallest thing which people can use. And this might be very reminiscent of the startup approach. You don't build something in isolation. You don't build something which people will not use. You build something which you can take to the customer, to the user, put it in their hands and see how they react, because you want to learn. Even after learning about the company and about the people in the beginning, you still will see that many of the hypotheses you had implicitly will probably not hold up. So it's very important to have something working and something you can iterate on very early. The earlier you can make it a bit easier to make the next dashboard and the next report, the earlier you can learn what actually is hidden inside of the data. And I don't mean the inside, but I mean like the nasty details which you did not notice when you started building your data pipeline. A very good idea is when you have data all over the place, for example, in different analytics tools and some internal Excel sheets, you want to get it into one place. You want to have a data warehouse. It might be a simple database. It might be a PostgreSQL. It might be something made for analytics. It might be even a silly file on your hard drive. But basically, you want to have processes which get the data out of those disparate data sources and get them into your single point of truth, which you can hopefully reproduce on any given day. So to do this, what you want to do is probably you want to use some kind of batch processing. Every night you get the newest data out. And when your processes are made the right way, you can run the data gathering step for a particular day, any day in the future, you will still get the right results. If not, you might want to make it a bit more resilient. And you want to get as much of the raw data out as possible. So don't simplify just yet, just get all the raw data, put it into one place, and from there you will be able to work with it. Some people call this approach a data lake, but it's not necessary to put a label on this, in my opinion, when you're working with small data at least. So what can you do to make this reliable? What can you do to make this something which will not drive you crazy in a month, in 3 months? I think it's very important to reuse the stuff which is already out there. You don't want to reinvent the wheel. You should know about ETL tools. You should know about workflow engines, which is my favorite part of working with data. Because for most part, ETL tools are more like, you click, you drag and drop. Workflow engines, at least the ones I know, are made to work with code. And I will present you my favorite one in a bit. But once again, while building this, while working with data, you want to focus on results. And in my opinion, how you get results inside of a company is not to work closely with one team or with one person, give them everything they need, but to start working with as many people as possible and see where their low-hanging fruits are. So maybe you can do something to make the life of the CEO a bit easier, maybe something of the marketing people a little bit. And those are relatively easy to get, usually. It's relatively hard to solve all problems, but it's easy to start solving a few, and the people will be happy. And in the beginning, at least, you get more bang for the buck in the meaning of ROI and in the meaning of people who actually believe in what you do. All right, so the MVP approach basically is build something small, work for people, and do something which helps a lot of people without investing too much work. Here are the tactics for this. You should not be rolling your own home-baked scripts. If you're having a bash script which you just wrote and you think that it's a quick way to fix the problem, it's probably not, because there is more to the problem than you have considered when you're getting into the area of data engineering. You have to think about what happens when you move on to another problem. Is this project which you are going to hand off to somebody else, is it extensible? Is it able to grow without you? Is it understandable? And in this case, uniqueness is really bad. So if you create a unique solution which nobody knows about, chances are the new person who comes in to look at it, they are going to struggle at several places. The learning curves will be not nice. They will not be able to take the knowledge with them when they do something else in a few years. And this will result in a higher maintenance time and tricky bugs and probably other kinds of code smells, and also unexpected failure modes. So there's a lot which can go wrong when handling data. When you will be dealing with Luigi or other workflow tools, what you will see is a set of features which has been found out to be very, very, very important. And when you start out writing your own scripts, you will not think of all the things which can go boom. So it's just the right approach to use as much of the advantages you can get. And this is by reusing the stuff which is already out there. And these are workflow engines. Workflow engines, basically, a quote from Wikipedia, orchestrated and repeatable pattern of business activity. This is a bit general, but it's used to build pipelines of data processing batch jobs, basically. They can be complex, they can be long running, and usually the workflow engine will have something in it to handle errors, to let you know if something goes wrong, to make your code reusable, and to take care of all the boilerplate, or, well, not all, but probably most of the boilerplate which you will need in the beginning. And also play nice with other tools to provide logging, monitoring, and stuff like this. Also, you'll be able to get help, of course. And the workflow tool, which I mostly recommend for people who don't have hard requirements, who don't really know what to pick, it's Luigi. Luigi, it's a bit older. It might be even ancient by tech standards. It's from 2013. It was first released. And it was released at Spotify. And it's used for lots and lots of data at Spotify. Basically, what you can do with it, you can run other parts of code. You can run Python code, which is made part of the Spotify workflow engine script. You can run Hadoop jobs. You can do all of these things. And this is the central part, the central glue, which keeps everything together. Oh, wait. I said the year wrong. It was 2009, not 2013. So beyond ancient. And the nice thing is, Luigi has been in production use for a long time. And there are a lot of people who have used it, and a lot of errors and mistakes which have been found and documented. The documentation is really nice. It's written in Python. It's written to be modular and extensible. And what it basically does is you tell it what to do, what depends on what, and it builds a acyclic dependency graph from it. So you say, like, first we need to get the data out of the database and save it in the secondary database, and then we need to take this data and create 3 different views on it. Then you get this kind of tree. where you don't have anything depending on each other in circles. And once you run your data pipeline, Luigi will take care of executing the tasks one after another, retrying things, and all of this nice stuff. So please take a look. Below is a link. It is a presentation by one of the initial authors of this workflow engine. It's really worthwhile to understand it. All right, so MVP data approach and the detectors. In conclusion, about this whole webinar, what I want you to take away from this is you should be thinking about the business value. I don't mean to be annoying, and I don't think you can think or talk too much about this. You are there to make a difference for a business, and handling the data is just a small part of it. Let's start with understanding the business. It might take some time. It's something which is performed iteratively, but it's a very good time investment. And usually, once you understand the business, once you have dealt with the problem domain and know what you want to achieve, the tech choices are not that hard. At least in the beginning, at least when you don't have big data. So what you want to do is you want to make it easy to learn and iterate. You want to get data into one place. You don't want to use home-baked scripts. And if you're not sure what to do to orchestrate all of this data handling stuff, you should take a look at workflow engines and Luigi in particular. So that's it for me. If you want to get in touch, if you have questions afterwards, you can drop me an email at the address below. It's data@thesuperlove.com. It's basically my name. And I would be very glad to hear from you. Anyway, if you have questions, you can ask them. I'll be sure to answer any you have.
Yeah, thank you, Vlad, so much. I'll just switch quickly to the webcam. And if you guys have questions, you should briefly post them here in the chat below. There is a dedicated tool on the live streaming. We will just give you a couple of minutes to sort it out, and we will gladly, or actually Vlad will gladly answer your questions. Otherwise, I will, of course, leave. There you go. Otherwise, of course, don't forget the email here to post questions directly to Vlad regarding the presentation of any data engineering, your expertise, if you're looking to a career in data engineering, which was definitely the goal of the webinar. And if you guys have questions regarding, of course, Beyond Machine and our events and our workshops, or if you want to join, if you want to sponsor, this is my email. It's lele@beyondmachine.com, but check on the website beyond-machine.com, and you can sign up for the newsletter, or you can buy the tickets directly. So again, beyond-machine.com. And to send question directly to Vlad, it's data@bsubalov.com. Perfect. Then if there's no additional question, I would say I will thank you so much for being here. And I will definitely welcome you to the next webinar that we will have very soon, and to our next events. One of them will hopefully also be taught by Vlad himself. So you'll be joining him for a real workshop. So thank you so much. You can, of course, see the replay of this video for a few days, and we might as well put it on the website. So thanks again, and have a good night.
Thank you. Bye-bye.